mute. இல்லைங்க இப்போ நம்ம ஓபன் பண்ணிட்டோம்னா அதாவது நம்ம வாய்ஸ் போகும். நம்ம பிளாக் பண்ணிட்டோம்னா வாய்ஸ் போகுது. சாப்பிடலாங்களா? Good morning, children. Today we are going to study about the P block elements. First of all, we want to know about, today we are going to study about P block elements. Children, P block elements that according to the periodic table, this is we have studied as periodic classifications. Periodic classification. Periodic classification. In these periodic classifications, we have numerous elements. These elements, according to our strategies, the elements and its properties, the elements are classified into 4 in kinds. There we have 14 elements here, 14 columns. That you see here, this containing 2 columns, this containing 10 columns. 1, 2, 3, 4, 5, 6, 7, 9, 10 columns. This containing, you know that there is 1, 2, 3, or you can start from here, that is counting from the 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, then 13, then 14, 15, 16, 17, then 18. This is 17 group elements, 16 group elements, 18. So here we have 1, 2, 3, 4, 5, 6. There are 6 columns, rows and columns. We are saying that rows and columns. Rows. 18. This only we call it as 18 groups. This only we call it as 18 groups. 18 groups. This is first row. You know that here hydrogen, here that helium, that is the 2 elements, you know, hydrogen, helium, you know that. This only we call it as first group. Sorry, first period. This is first period. That is periodic table. Periodic. This is now we are coming to know helium after hydrogen 1 atomic. This is atomic number 1, mass number 1.038. Now here we are coming to know helium, whose atomic number is 2. Here lithium, beryllium, then boron, carbon, nitrogen, oxygen, fluorine, then neon. So this is, you see, second period. Then we have third period. That you see here, third period, you are coming to know neon is a 10 atomic number. Then here that starts with sodium 11, Na11, magnesium 12, then aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, argon 18. This is nothing but we have studied as C, third period. Then here 18, 19, 20, 21. Here you are coming to know the point you should write here. This is the 18, here 19, here 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. This is up to this, we are saying fourth period. You please understand this. First period, second period, third period, fourth period. This is the point you should understand. That 19 says about this is potassium. This is a point. Calcium, scandium, titanium, vanadium, chromium is going on. This is the middle of the series is called D block elements. First of the series is called S block elements. Last of the series is called F block elements. And this series is called P block elements. The point you should understand here. Now we are going to study about what are P block elements. What are P block elements? The P block elements are the elements that the last electrons, please understand the point. P block elements, we are going to write these electronic configurations. You know that boron and its atomic number is, there is 5. Boron, atomic number is 5. Electronic configuration we can write 1s2, 2s2, 2p1. You see, now we are coming to know carbon, that is C6. Atomic number is 6, whose electronic configuration is 1s2, 2s2, 2p2. You come to know nitrogen, N7, whose electronic configuration is 1s2, 2s2, 2p3. Oxygen, its atomic number is 8, whose electronic configuration is 1s2, 2s2, 2p4. The fluorine, F9, whose electronic configuration is 1s2, 2s2, 2p5. The neon and its electronic configuration is, and atomic number is 10, 1s2, 2s2, 2p6. See, the electrons which are gradually increasing in its P level, that you can write P block elements, or generally we can write it as, this is the valence shell. You know that. This is a valence shell. This is called, the last shell is called valence shell. The valence shell electrons which are contained in ns2 np 1 to 6. 1 to 6. The electrons which are the last electron, which are going to accommodate in the last P level orbitals, or it is P orbitals, the last electrons enter into the P orbitals. So dissolved elements are known as P block elements. P block elements. This is a classification. This classifications we have studied as periodic classification. According to its characteristics, we can classify these elements into several kinds, namely the boron, aluminium, gallium, indium, thallium, Nignonium. This is nothing but carbon, silicon. That is the 13 group element or third A family. 14 group elements are 4th A family. 15 group element are 5th A family. 16 group element are 6th A family. 17 group element are 7th A family. This 18 group elements are called A group. You please come to know what are the elements which are belonging to this 14 group. Carbon, silicon, germanium, stannum, lead, that is fluoronium. Then you come to know nitrogen family. The nitrogen family which containing nitrogen, phosphorus, arsenic, antimony, bismuth, and moscovium. That is the element which is invented, which is synthesized in laboratory. That is Nignonium, and that is fluorovium, and moscovium, and livermorium. And that is that tungsten and agnosium. These are all the elements of to be synthesized in laboratory. These all elements are called laboratory elements and radioactive elements. So these properties of these elements are to be somewhat it is correlated and it is associated with these elements which is belonging to these all categories of 13, 14, 15, 16 and 17 and 18 group. Now you come to know very clearly the oxygen family is nothing but that oxygen, sulfur, selenium, tellurium, polonium. Now we come to know this halogen family. These halogen families are purely non-metals. We cannot see such a metallic character in this case of there is halogen family, and as well as there is that inert gases. All the inert gases are called these noble gases. These noble gases are called inert gases. This all belongs to these elements which are belonging to this category or to be noble gases. That is 8 group elements, which also to be all are non-metals. These non-metals are nothing but it's a metallic characters, and malleability and ductility or that metallic characters. The gaseous form or that there is to be the non-metallic characters. There is a point we should understand here, and this the elements which is to be represented as in blue colors. The elements which are represented as in blue colors. These are all we can say it is metals. You please understand. Except the boron in 13th family, that all others are that is metals. The boron only is having diagonally diagonal properties with that silicon. Diagonal properties are nothing but it is that similarities we can see in this case of there is boron and silicon. Now we come to know and this and stannum and lead is purely this metal, and bismuth is the metal and polonium is the metal. Now you come to know the best example for that is a point you should understand here, metalloids. The metalloids are silicon or called as metalloids, and germanium is a metalloids, and tellurium is a metalloids. Actually, the metalloids is the characteristics property which is not behaviors in a metal, which is not behaviors in a non-metal, and which is having metalloid characters, both metallic and non-metallic character, which are present in single element, is called we consider as metalloids characters. Metalloids. Now you come to know this is that bromine is a liquid non-metals. Bromine is a liquid non-metals. This is common to these p block elements. So here we have to specifically understand about this. What is the element which is belonging to this? That is 13 group and 14 group. The carbon whose electronic configuration is at 2 electron in its valence level. Nitrogen, you come to know, that is that point you should understand here. Boron, while we are according to this periodic properties, periodic classification, it is based on the electron which are occupying and accommodated. That each and every orbitals, yes, even a lost electron is accommodated in this s orbital. You take for example lithium, whose atomic number is 3, and you can write electronic configuration 1s2 2s1. The last electron which is present in this s orbital, so which is called s orbital, so it is called s block elements. You please understand, it is s block elements. Now the point is, you should understand that the position of the last electron which is belonging to this s orbital, so which is called s block element. The last electron which is belonging to this p orbital, so it is p block elements. So accordingly, we can give that classification, that is periodic classifications. That is nothing but periodically its property also changing, its characteristics also changing. That is, we can say periodic means it is that there are regular trend and regular changes, regular properties. That is periodic properties, we can say. Now we are going to see here, the point is, now we are going to study about the point here, the nitrogen family. The nitrogen family, nitrogen, phosphorus is purely non-metal, which ought to be belongs to this place. That you can see, for example, that is a point you should understand here. The zigzag, you see here from there, you see here, this all belongs to carbon, nitrogen. You see, this is a question, which are all to be a non-metal in these periodic, that is p block elements. You purely, you say this carbon, nitrogen, oxygen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17 elements are, that is to be called as, we can say, non-metals. That what are metallites? You see here 1, 2, 3, 4, 5, 6 elements are metallites. What are metals? You see here 1, 2, 3, 4, 5, 6, 7, 8. The 8 elements are called, we can say, metals. And here 17 elements are called, we can say, it is that is non-metals. You please understand what are called as non-metals. What are called as metalloids. Metalloids. What are called as metals? Except boron, all elements, 13 group, except boron, all are metals. All are metals. That is that things you should know about. And here the name which is to be derived from this Latin language, Greek language. So golden languages. Many scientific concepts and many scientific notations, names, which are derived from only that Greek and as well as Latin. Now you see, for example, 13 group elements are called icozones, and pure and 14 group elements are called hydrogens. This is that life producing element. Gen means it is producing. Genes are nothing but it is the producing. It is a life producing elements. So without this P block elements, no life can, no things to be survivable. Without oxygen, without phosphorus, without nitrogen. That 70% of atmosphere is to be containing only the nitrogen, and 21% are present only 21%. That is 21 point. Nearly it is, and pure which is containing of oxygen. That is the ratio in atmospheric ratio. This is a composition. This is a percentage composition of nitrogen. This is the percentage composition of oxygen in atmosphere. Such a very, very important. So nitrogen is the origin of life, the creation of life. Nitrogen only is used for this growing of plants, growing of human That is nitrogenous fertilizers. We are saying nitrogen is a fundamental for living. Oxygen is a fundamental for consuming, and there is each and every human cell is functioning based on only that oxygen. Such a very important element is an oxygen. That is nitrogen also we can say it is also a very important element because the life originated from only that nitrogen. That is, we have studied in botany and zoology, what is nitrogen cycle, that you know. So this is the concept, it is very important for the learning of the concept of P block elements. So all P block elements are very essential, that is, these all elements are called living elements. So here that what are the present in carbon, you know that no carbon, no life. The plant parts which is made up of carbon, the human body which is made up of only carbon, protein, fat, carbohydrate, everything is made up of only the carbon. So the carbon, oxygen, nitrogen, this is the majorly three elements. Even phosphorus which containing in your bone, sulfur also. So each and every element which are present in iodine is deficiency of iodine, that will be the disease goiter. Thyroid glands which are to be produced, which are to be is giving more trouble to the human body. So these all elements is very essential for living. Without aluminium, there is no industry, there is no aircraft, there is no aeroplane. Without this aluminium, there is no attention for home attention, household things. Without aluminium, there is no household things. So such a very important element, and here that you know the silicon and germanium is a vital role in electronicity, that is electronic devices. That you know electronic devices, the boron devices, all that, even a solar panel too, there is a simple cell phone batteries that is to be only functioning based on only that silicon chip, we can say. This is also essential for the modern science, the communication science, the communication is based on only that silicon and germanium. So this is that metal, non-metals, this metalloids, it's not non, this metalloids, both the metallic characters and non-metallic characters which are present in this case of silicon and germanium. So such a very important element, you know that. There is a point you should understand here, arsenic. The arsenic and antimony is the best example for the metalloids. The example for the metalloids, what's the question which is asking, and arsenic and antimony are the best example for arsenic and antimony are the best example for there is a metalloids. The point is, on pure the purely metal, we can say aluminum is a pure metal, gallium, indium, thallium. So this is that elements, and whose Latin name it says about aquazons, tritosons, that is nictosons, and chalcogens and halogens. And chalcogens are nothing but it is a ore producing elements. This is a ore producing element, and this is a salt producing elements. And this is called, we can say, inert gases. That I have given very clear the general electronic configuration for each and every group of the elements. So that you know this is 13 group element. I have given very clear statement. This is 13 group element whose electronic configuration is Ns2np1. You see Ns2np1. Now what is the meaning of Ns2np1? So now you are coming to know here the boron 2s2 2p. Now we come to know this is the base concept you should understand how to write the electronic configuration of aluminium. The 2 denotes it is the second period, and 3 denotes this belongs to the third period. Now we come to know aluminium and its electronic configurations. You can write for this aluminium and its electronic Al. 13 is its it is atomic number. You can write the electronic configuration 1s2, 2s2, 2p. That is that 6 and 3s2 and 3s2 and 3p1. You please understand. Now you see here that 3s2, 3p. This is, you write 3s2, 3p1. You see, ns2, np1. ns2, 2 electrons in s orbital. np1, p orbital, 1 electron. Now you see the n denotes principal quantum numbers. The n denotes principal quantum numbers. That principal quantum numbers is denotes the concept, you know, that here that atomic structure of any atoms or boron or nitrogen or boron or phosphorus or aluminum, this is nucleus. The first shell call, we can say n is equal to 1. The second cell is called, we can say n is equal to 2. The third cell is called, we can say n is equal to 3. And fourth cell is called n is equal to 4. Now you write n is equal to 1. This is according to principal quantum number. That it is the cell which can able to accommodate there is 2 electrons, 8 electron, 18 electron, that you know. So this is that that is to be the accommodation of this shell which can able to accommodate only there is 2 electrons. That is, we can write it as 1s2. So this one denotes n is equal to 1. That is principal quantum numbers. The point you should understand here, it is a very least fundamentals. That is, see here 14 group elements all belongs to this that ns2 np2 electronic configurations. And here there is a 15 group elements of nitrogen. You see ns2, there is a ns2 np3 electronic configuration. That is ns2 np3. That is 2p3. That means boron is having the last shell 2s2 2p1. Aluminium is having 3s2 3p1. Gallium is having that is 4s2 4p1. Indium is having 5s2 5p1. And thallium is having 6s2 6p1. And niconium is having 7s2 7p1. So we have only 7 periods. That you know, 18 groups. 7 periods, 18 groups. The point you should understand here very clearly. That is the things you should understand about this according to these p block elements and its characteristics property. And just we are going to study about. And before we are going to study about its electronic configuration, we want to study about this. What is the oxidation state also? What is the oxidation state and what is the number of electron in its last level? You see here 3 electrons are there. That means these all 3 electrons are going to lose by the atoms. That atom is having chemical properties by means of losing of electron and gaining of electrons. That both the characteristics property which is taking place in this atom to how to produce a chemical reactions. The chemical reactions are nothing but it is the tendency of an atom which can gain electron and which can lose electrons. The loss of electron also takes place and gain of electron by means of losing and gaining, there will be the chemical reactions. Your new product which is generated, your new product which is produced, that by means of only the loss of electron. So how many electrons which is lost by this atom, we can represent as an oxidation state. So boron family, all elements can able to lose the 3 electron. So whose oxidation state is 3 plus. That is the carbon family is having 4 electron in its outermost valence level. So now whose oxidation number is 4. And nitrogen family, that is nitrogen family. And here which is having, there is a 5 electron in each valence level. So 5 is its oxidation state. That means, what's the meaning for this one? You should understand that it can able to produce a numerous compounds. So now we are writing, that is N2O5, nitrogen pentoxide. This nitrogen pentoxide, what is the oxidation state of nitrogen here? This is 5 plus is its oxidation state. So that means which is going to lose, these all 5 electrons are going to lose by the nitrogen and gain by the oxygen. The electrons, this is one atom is going to lose the electron, one atom is going to gain the electron. Finally, what is produced? The chemical reaction is taking place and that new product is obtained. So nitrogen pentoxide is forming by means of this oxidation state. Now finally, we come to know here that chalcogen family and whose oxidation number chalcogen family is 4 forming family, which containing, you see here 6 electron in its valence level. So that means and can able to produce as 6 is its oxidation state. Now we are coming to know here that is that the halogen family, and here you please understand, and which containing halogen family, halogen salt producing family, which is containing 7 electron in its valence level. So 7 is its oxidation state. But here and inert gases which containing, you see here 6 electron and here 2 electron, totally 8 electron in each valence level. So 8 plus oxidation states are possible in some types. This is rare gases and it is inert gases. It is that is to be, we can say it is to be that the inert because it is chemically inert, which is not having any chemical properties, which is not having any chemical reaction. So these families are called, we can say, inert family. This is inert is not having, not active. Inert person means what? Non-active persons. That means these all gases are inactive, chemically inactive. But it is physical properties are active. This helium is useful in some other. There is a helium balloons used in metallurgical, weather forecasting is based on only the helium balloons. There is a meteorological department which is using the weather conditions where there is a rain which is going to cause, where there is a what's the temperature of the day-to-day, what is the day-to-day temperature which we are measuring by knowing this only that helium balloons which indicate us to what's the temperature today, what's the weather system today. This also we can monitoring by using helium balloons. Helium gas is filled in balloons, is helium balloons. The neon also to be used. Argon, krypton, xenon, all are very, that is important in medical science. So that is different. So that's why we can say it is that all these elements are very important for our living. So that is without these all B-block elements, there is no life existing, there is no survival of the life. This is a concept we should understand. Now we are coming to know, and here while we are moving down the groups, and here that elements and its electronic configuration, and its chemical properties, and its physical property, which are changing, that we have studied in periodic classifications, and that is as based on the periodic properties. So the periodic properties are nothing but just that atomic radii, ionic radii. That is a point you can understand here. What are the periodic? The periodic properties. Periodic properties. Periodic properties. The periodic properties are nothing but we have studied as atomic size, ionic radii, and then ionization energy, and electron affinity, and electron negativity, and dipole moments. These are all the points we have studied in periodic classifications already. Atomic size. See, while we are moving down the road, the size will get increases. The size will get increases. While we are moving left to right, that is down the groups. Moving left to right. This is periodic properties. The point you should understand down here, this is down the groups. This is moving left to right. The size will get decreases. The point you should know that you see here in this case of moving down the groups, the size will get increases. What's the reason? The quantum number is increasing. For the case of first element, that is boron, whose periodic number is 2, whose quantum number is only 2, the atomic size is small. Whereas we come to know there is that point you can understand aluminium, which is going to this, that is that you see in aluminium and its electronic configuration, we have studied already, and here that aluminium and its electronic configuration and its atomic size is entry the principal quantum number 3. So the size is increasing. The atomic size is increasing. The point you should understand why that we are moving down the groups and here principal quantum number is increasing. The atomic size is increasing. while you are moving left to right, the additive electrons are added. You see, for example, boron, the last electron entered into the p orbital, 2p orbital, and next element is carbon. That is the last electron which is entered into the same 2p orbital. That is nitrogen, whose atomic number is 7. The last electron enters the same 2p orbital. That oxygen, you can take here the last electron which is assigned to the same p orbital. You see fluorine, and whose atomic number is 9, and the last electron which is entered into the same p orbital. That is 2p orbital. Neon, whose atomic number is 10, and here and the last electron which is entered into the same 2p orbital. You see, in all cases, the last electron which are accommodated only the same 2p orbitals. The same 2p orbitals. So now what's the meaning? That you are moving left to right, the added electrons are added to the same shell. The added electrons are added to the same shell. Added electrons are added to the same shell. That is why, if that's to be, you see, here only the point you should understand here, boron which containing 5 protons. 5 proton, whereas here 6 proton, whereas here 7 proton, whereas here 8 protons, whereas here 9 protons, whereas here 10 protons. Now we are moving left to right. What will happen? The nuclear charge, proton number increases. So attraction will get increases. So size will get decreases. This is a point we have studied already. While you are moving down to those, what will happen? The added electrons are added to the new shell. The first group we can set it as n is equal to 1. The second group n is equal to 2, n is equal to 3, n is equal to 4. That all electrons are going to the new shell. So the size will get increases. If the size is increasing, what will happen? Attraction will be decreasing. Attraction is decreasing, what will happen? Size will get increases. This is periodic properties. You have studied already. The electronegativity, electron affinity also based on the size. So electron affinity, while you are moving that left to right, what will happen? The size of atom decreases. The size of atom decreases. Size of atom decreases. What will happen? The attraction will get increases. While you are moving down the road, the size will get increases. The attraction between outermost and the nucleus will get, attraction will get decreases. Why? Because the electron which is coming here to this is the position. This is a nucleus position. The distance between the electron and the nucleus will be greater. So greater the distance, lesser the attraction. Lesser the distance, greater the attraction. Lesser the distance, greater the attraction. The distance, the attraction is based on. That is we have studied as electron affinity. That is we have studied as electronegativity. It is attracting property of an electrons by the nucleus. This is we have studied as electronegativity, electron affinity. These all elements and its properties also based on the concept of that is a periodic table. That is the element which are present in this periodic table. So this periodic table is designed according to its all properties, all chemical properties, all physical properties, all diagonal properties. All these, there is similarities and dissimilarities of these elements. Many disparities we can see in these periodic tables. These all disparities all to be is rectified, and then it is to be coming to place in a single place. That is called, we can say, periodic tables. That periodic table which is to be designed based on its physical and chemical properties. The point you should understand here. So now we are going to study about what are the families of the elements. You are very clear. And what is that aluminium and its importance? You are very clear. And what's the general trend about these p-block elements? You are very clear. That already the properties of the elements are largely depend upon this electronic configuration. That I have mainly insist that what's the electronic configuration of these elements. And electronic configuration and oxidation state also I have very clearly explained. And that is the point I am coming to say here. That is, see, while you are moving down the groups, there is the one special character which is influences in this case of p-block elements. That is called inner pair effect. That is that inner pair effect. Because of this inner pair effect, the thallium can able to produce 1 plus oxidation state. The first of the series boron aluminium. Aluminium is carrying 3 plus oxidation state, whereas thallium can produces only 1 plus instead of 3 plus. Why? Because the thallium which containing that NS2 NP1, this one electron only can be undergoing chemical reaction. This one electron only involving this chemical reaction. This orbital electron, this is s orbital electron, is not involved in the chemical reaction. So that is inert. There is no action. That is inert. This is only in action. That is active. So this one electron is active. So thallium can able to produce as there is 1 plus oxidation state. That is mentioned. That is your carbon can able to produce as that is +4 to that is +4 to -4. There are 2 oxidation state which is exhibited by this carbon. The point you should understand. You please understand the point. What is here in carbon tetrachloride? You please understand the point in carbon tetrachloride CCl4. Chlorine is negative charge. Now it is act as a positive charge. So now in these cases, carbon can exhibit there is 4 plus oxidation state. The point is you should understand. The point you should understand here that the carbon can able to produce as 4 plus oxidation state in all cases. The carbon can exhibit 4 minus oxidation state also. Now we are going to see silicon and germanium lead. See the lead can able to produce as 2 plus along with that 4 plus. Lead can able to produce as the variable oxidation state, that is lead can able to produce as 2 plus and also 4 plus. There are 2 oxidation state which is exhibited by this lead. So this is the point you should understand and how this all concept we can analyze based on its oxidation state. Now we come to know here that nitrogen family can able to produce as N, that is nitrogen can able to produce as 3 plus oxidation state and also 3 minus oxidation state. Now in this case of 3 minus, you take for example that is ammonia. That is the point you should understand. Ammonia NH3. Now in this case, hydrogen is act as a plus charge. Now it is act as a minus charge. Now you see, for example, phosphine, that is PH3 phosphorus. Now in this case, and hydrogen is to be producing, there is positive charge, and here that phosphorus can producing negative charge. This is the point you can write. How many pluses are there? Always the same number of negative charges also there. Then only the compound will be stable. The things you should understand. So now in these cases also the nitrogen can able to produce this, and here it is at +3 oxidation state and also -3 oxidation state. Now you come to know, and here that the next family is called what is that? Here chalcogen family and salt producing family. This can able to produce as 4 plus oxidation state, and here and also and 2 plus oxidation state and 2 minus oxidation state. You know that oxygen always 2 minus. Oxygen always 2 minus. And then this is a point you should understand here. And 2 plus also possible that oxygen. 2 plus oxidation state also possible for this case of oxygen. That is 2 plus oxidation state. And here that elements which are to be polonium, and these are all that elements is having 4 plus oxidation state also. Now we come to know fluorine family +5 oxidation state and +3 oxidation state and +1 oxidation state. The -1 oxidation state is a very famous, and it is the only oxidation state of all the halogens. Fluorine is carrying -1 oxidation state. Why? Because this is that only is a stable oxidation state that they come to know Cl minus, Br minus, I minus. These are all these oxidation state. That means that you see here that electronic configuration of fluorine, and here and that last that electronic configuration of fluorine you come to know, and here this is the electronic configuration 2s2 2p5. So here 7 electron is present in its last level, so which is going to gain 1 electron. Now it is going to attain the octet. By gaining of 1 electron, this whole family are gaining 1 electron to attain the octet. And this gaining, because of the gaining, which is going to come, which is we can represent it as F minus, which is we can represent it as Cl minus, which is we can represent it as Br minus, which is we can represent it as which is we can represent it as I minus, Br minus, Cl minus, F minus. The point is, this is the oxidation state. And here the neon family, this is halogen, this is inert gases family. All this is also belongs to this oxidation state of 6 plus and 4 plus and 2 plus oxidation state. So these all elements also can able to produce numerous compounds, especially krypton and xenon and argon. All these elements able to produce compounds, that is chemical compounds. So now this is elements also very important to know about is the chemical reactions, whereas helium and neon is not undergoing chemical reactions. This the point you should understand. So this is the entire concept and very detailed study about these all p block elements. You know that electronic configurations, and you know how these electronic configurations are represented, and these all families. You know. Next we are going to study about and which are the elements and what are the characteristics, properties, and we are very clear. The point which is given out is there is ionization enthalpy and electronegativity, and here it is that anomalous properties of these first elements. Anomalous behaviors. That anomalous behavior is based on this. That is that how far these elements are differ from one another. This we have studied as anomalous behavior, dissimilarities in properties. Analogous, dissimilarities in properties. Anomalous, dissimilarities in properties. For example, you come to know boron whose size is very small. While you are coming to down the curves, thallium is having greater the size. So there is no similarities we could find in this case of boron and a thallium. You come to know boron is the metalloids. It is a non-metal, purely non-metal. This is a purely non-metal. But here thallium is purely metal. So even though which are all belongs to the same group, same family. This is boron family, this is carbon family, this is nitrogen family, this is oxygen family, this is fluorine family, this is inert gases family. These are all showing similarities in oxidation state. These are all showing similarities in electronic configuration, but which are dissimilar in its properties. Differ from its properties. In what way which is differing? The point you should understand, the size is differing. One can have smaller size, one can have greater size. If there is a smaller size, greater electronegativity, the point I have given already. That is the point you see here. If there is an atomic size is greater, the electronegativity is lesser. The electron affinity is lesser. The atomic radii is greater. The atomic size is greater. The point which is differing. Even though these all elements are in same family, but the characteristics is changing, the properties are changing, chemical properties are changing. The point you should understand. Next are things you should know about what is that and elements and which are differing from one element to other elements. You have studied as that is anomalous properties of these p block elements. That you know the 13th group element, that is the boron. And it is metalloids, but all other elements are metals. That is anomalous. What's the question which is asking? In 13th group element, which is anomalous element, which is not, which is differing from one another, which is differ from there is this group. Boron is differ from these all elements. Why? Because that aluminium, gallium, indium, thallium, all the purely metals, but boron is metalloids, so it is differing. So that is dissimilarities. You have studied as the point you can write. This is you have studied as anomalous behaviors. The anomalous behaviors, and here in 14th group, the anomalous behavior is boron. In 14th group, that is the point you can write, and that is that silicon and boron are similar in their all acidic natures and all the properties. So similarities are there. We can say it is we have studied as that is diagonal properties. Similarities are there. We have studied as diagonal properties. The point you should understand. And boron, silicon, all can produce as covalent compounds. Covalent halides, covalent hydrides. Boron hydride is called BH3. That is the point you can write. And silicon, SiCl4, boron BCl3, these are not possible. That is boron trichloride, silicon tetrafluoride, silicon tetrachloride. This can able to produce halides. That's why we can say these are all amine. But these halides are that covalent characters. Whereas the aluminium can produce the halides, that is aluminum chloride, but it is not having this covalent character. Here we can find ionic characters. So this is the point we can discuss many points regarding to these. That is that homologous and anomalous properties. Now we come to know anomalous properties, and here, for example, that it can go for this carbon family. The carbon family, carbon family, carbon is unique. That is, carbon is having ability to how to produces multi bonds. Nitrogen in nitrogen family, the nitrogen can able to produce a multi bonds. Nitrogen triple bond. There is a multi bonds. But these kinds of characteristics we cannot find in this case of silicon and germanium and stannum. And here it is a nitrogen, and even in this phosphorus, we cannot find such a characteristics of multi-valency and multi-bond characters. So the point is, you are very clear here how we can distinguishing this. The point of that is a multi-bond characters, and fluorine is unique elements. This is having highly there is highly electronegative elements we are seeing. This is always to produce a negative charge, that is -1. The point you should understand. So now just we have discussed about these many points regarding to this periodic table, and that is especially in these p-block elements. And just I have given very detailed report about this, the p-block elements. And next tomorrow we are going to study about this, that all characteristics properties of p-block elements. Thank you to that. Actually,